Line renderers are a built-in component of Unity that render line segments along a list of vector 3s. Recently, I've had the use case to use it as a way of indicating the path that an object in the game world will follow according to some provided vector 3s. In order to make the path look more interesting, I wanted it to fade in and out in the manner displayed here. I came up with a fair solution and will now share how it works. I've prepared a sample scene with 7 positions on it. They're empty game objects whose positions are noted with a gizmo. We'll be connecting these positions with our line renderer, which we will now create. Let's add the Unity line renderer component, and we'll notice these properties. We have positions and color. In order to make it clear, I'm going to set the color to be green, a nice bright green, on both sides. And we will need a script, which I will create now. I'll call it guiding line, but you can call it whatever you want. And let's take a look at this script. The first thing we'll do is have our public list of transform. These are going to be our positions, and we'll set them up soon. We will also want a property for the speed that we want the fade to go in and out at. We will need a reference to the line renderer on this game object. And in order to indicate whether we're fading in or out, we will have this int direction. Let's get our reference to our line renderer on our component. And line renderers can be a little fickle about how they get their positions set. So the first thing you have to do when setting a line renderer's positions is to update the position count to how many positions you're going to want. We know how many positions we want. We've got this list here for indicating that. Then we actually set the positions. And you set positions with an array of vector 3s. And those vector 3s will be the transform positions of our positions. So if you're unfamiliar with LINQ, LINQ is just it is a tool that'll just help us get those transform positions. We can go into that in another video if needed. Okay, so let's take a look at how this works just on its own. We'll come back here. And our line renderer has a list of transforms and a speed. The speed isn't incredibly important right now, but I'll just set it to something really low. And I will lock this component, get all of our transforms, and put them in this list. Now, if I'm right, this will just display the line along these segments. Great. And it's nice and purple too. I don't know why that's purple. Let's take a look. Maybe it's because we don't have a material. That's funny. Let's try again. Now we have it. Good. Alright. Let's talk about what we need to accomplish. Basically, we're going to have to take the alpha on either side of the gradient and fluctuate it up and down so that it appears to kind of be moving along in the line. So that's what we're going to try to accomplish in this upcoming method. It's going to be a coroutine because it will be happening over time, and I like to use coroutines to help visualize things that happen over time. We'll get the line renderer's color gradient and alpha key information, and we're going to be looping through however many alpha keys there are, which let's take a look at how that is. This is the gradient, and this is alpha key 0, and this is alpha key 1. So we're going to be looping through those. You could have any number of them, which is why we're using a for loop. We're just going to stay with 2. First, we'll get our reference to our alpha key, and then we will have this while loop. So we are taking the absolute value of the alpha, and if it's less than 1, we'll stay in the loop. Now, the reason for the absolute value we'll come back to. Next, we will get the delta for how much we're going to change the alpha by, and that is determined by the speed, which we have made a property of the line or the guiding line object. Next, according to whatever direction we're going, we're either going to want to take the minimum between 1 and the alpha key's alpha plus the delta, or the maximum between -1 and the alpha key's alpha plus the delta. We'll come back to what that means soon. But once we get our alpha key set, we're going to set the alpha key back to the alpha keys array, assign it back to the gradient, and then assign it back to the line render. It's pretty kooky how all these assignments have to go down, but that's what I ended up with. And this will be on a frame-by-frame basis. We will yield return null here because we want this to happen only once per frame. Over time, the alpha will be going up or down. So, as we said earlier, as long as the alpha key's absolute value of the alpha is less than 1, we'll stay in this loop. It will pop out as soon as the alpha key's alpha reaches 1 as an absolute value. Once we have reached 1 for both of the alpha keys, as soon as we're done, we will set them to just be just less than 1. The reason we're dancing around 1 so carefully with all these calculations is because if the alpha key value falls outside of 1, Unity freaks out a little bit. So we're just being extra careful that we always stay inside of 1. And once we set these keys, we set them back to the line renderer. And now that we've completed going through the alpha keys, we'll invert the direction. At this point, we've either become fully visible or fully invisible, and we want to start going in the opposite direction. And then we begin the coroutine again. Now that we have all this in place, we should see the fade effect occurring. Okay, I think I see it fading. Good. Alright, so I guess we just have it going really slow. So let me just let me speed that up a little bit. 0.001, let's make it 0.01. Good, it's 10 times faster. And that's how you would make a line fade in and out like this. Thanks for watching. Hopefully more tutorials to come.